Hi, today I'll be showing you how we can turn on the LED of a STM32F103 microcontroller without using the hardware abstraction layer. We are going to do this by only manipulating the resistors. You can use your STM32Cube IDE to write your programs and flash your microcontroller, but I will not use it. Here I have the basic program structure, and the first thing we need to know is which pin the LED is connected. In case of the STM32F103, the LED is connected to the port C pin 13. So in order to use the port C P13, we need first to enable the clock of this port. To enable the clock of the port C, we need to find out what is the address of this port, and we can find it in the reference manual of the microcontroller. You can go to the memory bus architecture, expand it, and memory map. The peripheral responsible for enable the clock is the RCC, or the reset and clock control. This peripheral starts from the address 4002.100. So this address is the base address of the RCC. So let's copy this and put in the code. So here in the code I will define this, that we have the RCC base and we have the address. Since the address is an assigned integer, we can put the letter U in the end. The next thing we need to know is to find where the port C is. So to do this, we can go back to the reference manual, and you can see that the port C is connected to the APB2 bus. With this information, we can go now to the RCC registers, and we can see that we have the APB2 ENR. This register is responsible for enabling the clock for that particular peripheral. In this case, we want to enable the clock for port C, and here it is. To enable the clock for the port C, we can enable the bit 4 of the APB2 ENR register. So now how do we access this APB2 ENR register? You can see here that every register has an address, okay? This address is the offset of the base address. So in this case, since we are using the RCC, we know that the RCC starts from this address, and the register we want to access starts from this address. So all we need to do is to take the base address of the RCC and add, in this case, 18. Then we can now access this register. So let's do this. Let's copy this, the name of the register, and let's go back to the code, and let's define the RCC ENR will be the RCC base address plus the offset. In this case is 18. We also need to cast this value, which will be the unsigned int 32. If we leave this macro the way it is every time we need to access this register, we need to use the asterisk in front of it, like this. So to avoid using this asterisk, we can dereference this here. So all I need to do is to put an asterisk here. So like this. So now we can enable the clock for the port C. To do this, we can use the RCC APB2 ENR and enable the bit 4. Now we need to go back to the memory map and find the port C. As you can see here, the port C starts from the address 40011000. So this is the base address of the port C. So let's copy and paste in the code. So let's define the base of the port C here. And now if we go back to the documentation, we can go to the section GPIOs and we can see the GPIO registers. The first thing we need to do in the GPIO is to configure the mode. For this we have two registers. We have the port configuration register low and we have the port configuration register high. The difference between these two is that with the register low, we can only access the port 0 to 7. But the LED is connected to the port 13. So we need to access the register high. And the register high, we can access the ports 8 to 15. And since we want the port 13, we can use the bit 20 and 21 to set the mode. And also we need to access the bit 22 and 23 to set the port configuration. So before setting the values in this register, let's first access this register. So we can see that the offset of this register is 04. So all we need to do is to add this 04 in the base of the GPIO port C. Let's copy this name and let's go back to the code. Let's define this port C. This will be the RCC base plus the offset, which is 04. As we can see, we are going to modify 4 bits in this register, which will be the bit 20 up to 23. A good practice before setting any value is to reset the values that we are going to set. So in this case, let's first reset the values in this 4 bit. So let's go to the code. And now we can reset using the GPIO CRH. So by doing this, we are resetting all the 4 bits. The first bit we are going to set are the bits 20 and 21 that are responsible for setting the mode. As we can see here in the description, we can see that the mode we can use as input, output mode maximum speed 10 MHz, 2 MHz or 50 MHz. Since this microcontroller, the maximum speed is 8 MHz, we need to use this option, maximum speed 2 MHz. So in the bits 20 and 21, we can set the value 1, 0. So let's back to the code and set this value. So by doing this, we are using the mode output maximum 2 MHz. This is all the configuration we need to start outputting the data. Now all we need to do is to access the register responsible for output the data. So if we go back to the reference manual, this register is the ODR, or output data register. So this register is responsible for outputting the data. This register goes from 0 up to 15, which is the number of the ports. Since we are using the port 13 to output the data, we need to enable the bit 13. The offset of this register is 0C. So let's define this register. Let's go back to the code, define. So now here I have the register, and we need to enable the bit 13. So by doing this, the LED will turn on. But now let's put this inside of a while loop, and let's change this. Here I'm setting the bit 1. In a while loop, I want to make the bit 0 if it is 1, and make 1 if it is 0. So I can do this by doing the XOR operation, like this. It will flip the bits. So this will turn on and off the bit. So now let's add some delay. Let's call a function called delay, and this function will be a loop that starts from 0 and will go to 200,000. So with this, let's flash the microcontroller. So as you can see, the LED is blinking, and let's try another thing. Let's make the LED blinking faster. So let's remove the 200,000 to 50,000, and let's flash it. As you can see, the LED is blinking and it's working.